Okay, dear students, let's move on to question number 31. Question says if B is the inverse of a 3 by 3 matrix A, then the sum of the values of alpha for which determinant of A plus 1 is equal to 0 is. Coming to solution part. Let us decode in math language. B, okay, matrix B is, so equal sign, inverse of matrix A. So inverse of matrix A. Then we have to find sum of the values of alpha provided determinant of A, this meaning determinant of A plus 1 is equal to 0. Now since determinant is there, so take determinant on both the sides. Determinant of B is equal to determinant of A inverse, which is also same as determinant of A whole power minus 1. Now here determinant of B, from here let us try to evaluate. That will be 5 2 alpha, then 1 0 2 1 alpha 3 minus 1. Okay, and this, don't forget, this is 1 by determinant of A. That's why the properties are so important. And you can see 0 is here, so I can think of expanding along the second row. When I'm going to expand along second row, surely this, don't forget that sign, no, diamond. Yeah, there's a minus here and minus here for second row. So minus here, then a minus here. So now expanding along R2. So minus 0, if everything is 0, then plus 2. Leave the second row and second column. We are going to have determinant of 5 1 alpha minus 1. Then minus 1. This minus came because of this expansion cofactors, correct? Minus 1. Leave the second row and third column. We'll get 5 2 alpha, 5 2 alpha, alpha 3. Just cross check, and is equal to 1 by determinant of A. Cross check if everything is fine. Okay. Yes. Now simplify. Plus minus. So 2 times of 5 into minus 1 is minus 5. Then minus 1 into alpha is alpha. Then minus 1 times of 5 into 3 will be 15. Then plus into minus is minus 2. Alpha into alpha will be alpha square. Let us write this 2 properly. Is equal to 1 by determinant of A. Simplify. 2 into minus 5 is minus 10. Then minus 2 alpha. Minus 1 into 15 is minus 15. Minus plus 2 alpha square is equal to 1 divided by determinant of A. Or we can say that 1 by determinant of A. 1 by determinant of A is equal to 2 alpha square. Then what? I have one line here. Minus 2 alpha. Then minus 15 and minus 10 will be minus. Yeah, minus 30, minus 25. Minus 25. Now, since I want determinant of A here, I better have got in denominator, so take reciprocal. So I'll get determinant of A is equal to 1 divided by 2 alpha square minus 2 alpha minus 25. Put this in equation number 1. So I'm going to have this. So I'm going to get, so I erase this part of the question. I'll do one thing. I'll simplify here only. So when I'm going to substitute here, what we are going to get? Determinant of A. Okay, I mean to say I'm going to substitute here. So I'll get 1 divided by 2 alpha square minus 2 alpha minus 25 plus 1 is equal to 0. So if I take the LCM, see, there is a fraction here, 1 divided by this plus 1. I think that is 1. LCM of A and 1 is A. So LCM of this term and 1 will be the same term in the denominator, this entire expression. So I am going to have 2 alpha square minus 2 alpha minus 25. If I divide this one by this, I'll get 1. 1 into 1 is 1. Then again, this entire term, if I divide by 1, I'll get the same term. So multiply with 1, I'll get the same again. 2 alpha square minus 2 alpha minus 25 is equal to 0. Cross multiply, I'll get 0. Right hand side as it is. Now here, remaining is 1 plus 2 alpha square minus 2 alpha minus 25 is equal to 0. So here 2 alpha square minus 2 alpha minus 25 and 1 will be minus 24. Now I can divide 12 by 2 as a factors of 2 we can see here. So I am going to have alpha square minus alpha minus 12 is equal to 0. They want sum of the values of alphas. If I factorize it, I'll get the what? Two roots. I have to sum them. Other way for this from here will be, if I have a quadratic equation ax square plus bx plus c is equal to 0, obviously a is not equal to 0. Then let us suppose the roots of this is alpha and beta, then sum of the roots, that is alpha plus beta will be minus b by a, and product of the roots is given by alpha into beta, which is equal to c by a. Okay, so if it is sum of the root I want to find, in place of factorizing and getting the roots, just whatever the equation there, x multiple, that is b, divided by a with minus sign. And how to remember this sign also very simple. Here it is minus, it is plus, just you can say plus, minus and plus. Divide by a here, divide by a here, you will get a by a will get cancelled. Here you will get minus b by a, and here it is c by a. So x multiple minus b by a will give you sum of the root, and constant c by a will give you product of the root. Now if I compare that one with here, ax square plus bx plus c is equal to 0. X square multiple is here, alpha square multiple is 1, so a is equal to 1. X multiple is b, so alpha multiple is minus 1 here, so b is equal to minus 1, and c is a constant which is minus 12 here, c is equal to minus 12, and yes, in place of x we have got alpha. So the sum, whatever they said, sum is given by minus b by a, minus b by a, minus b by a. So minus of b value is minus 1 and a value is 1. So minus plus 1 by 1 is 1. So the answer is Bablu. Sum of the values will be 1. Now you may be thinking, sir, too much calculation this problem had. What about the other problem where we had less calculation? See, surely out of 60 questions, there will be minimum 4 to 5 questions where you have to think a bit more. As I said, no, our target is 55 plus nothing but 60 only. So surely I will be taking some problem where it's going to surely pick you that you have to have more and more knowledge. And this type of problem should not demotivate. Let us suppose you leave this problem. 55 problems are still there to target. Okay, fine. Kindly make a note. I'll erase this. Okay, recording. Yeah, dear students, let's first move on to this question number 32. Okay, right of the marker. See, we had one big problem, but see, so many problems are not so lengthy. I mean, say lengthy problem. Now you can see this, the usual one which is asked. I want to cover everything. Our target is 55 plus, actually 60. That's why plus is given. If a square minus a plus I is equal to 0, then the inverse of a is. This is actually our 4-marker question type. Matrix A is not given, only you have to find A inverse, and in the option you can see A is given here. So coming to this, pre-multiply or post-multiply, let us say pre-multiply, left to you. Pre-multiply by A inverse on both the sides. Then A inverse A square minus A inverse A plus A inverse into identity is equal to A inverse into 0 matrix. A inverse A square. As see, rudely speaking, we can also say bases are same at the power minus 1 plus 2 will be A, which is actually wrong. I should write this as A inverse into A, then minus A inverse into A. We know the property. Let us stick with the usual way itself, because later on, no, there should not be a contradiction. You are thinking there. Then plus, recall again that whenever you multiply any matrix A with identity, you get back the same matrix A. So A inverse into I will be A inverse. And don't forget, whenever you multiply any matrix A with 0 matrix, you get what? The 0 matrix. A into 0 matrix is 0 matrix. So A inverse into 0 will be 0. Again, if I group this, A inverse into A will be I, into A minus I plus A inverse is equal to 0. I into A is A minus I plus A inverse is equal to 0. Since I want inverse of A, nothing but this, correct? Solve for A inverse, transpose this term here. We are going to have from here A inverse is equal to A minus I. When I transpose, I'll get minus A plus I. Minus A plus I is then which option? Minus A plus I is then option A. Option always correct. So we have problem with this also, where the things we will get in no time. So I hope that working is correct. A into I is I. Yeah, fine, it's correct. Now come to question number 33. If A is a symmetric matrix of order 3 by 3, then A square inverse is equal to what? This I gave one list of property in which I commented that A power n whole inverse is same as A inverse whole power n. So it means in place of n we have 2. So A square the whole inverse is equal to A inverse whole power 2. And this is then which option? A inverse the whole square is option C. Option Chalu is correct. Okay. Next question number 34. If A is a 3 by 3 matrix such that determinant of 5 times of adjoint of A is equal to 5, then the value of determinant of A. See, focus on this. Focus on this. We have a scalar. See, we had one important result. Determinant of scalar into a matrix is k power n into determinant of the matrix A, provided k is a scalar, k is a real number. Now in place of k we have 5. A is what? Matrix. Adjoint A is also a matrix. Adjoint A is always a matrix, we have already discussed. So in place of k 5. So when I am going to continue, let's write it again for better understanding. Now see carefully. In place of k we have 5. So it is k power, nothing but 5 power n. N is what? Order of the matrix. Here the order is 3. So n is equal to 3. So 5 power 3 into determinant, whichever matrix is there, that determinant. Here it is adjoint here. So determinant of adjoint of A is equal to 5. Here 1 5 will go. So I'll get 5 square here, correct? So I'm going to have 5 square, nothing but 25. This is 5 square minded. Then determinant of adjoint of A is determinant of A whole power n minus 1 is equal to 1. We call determinant of adjoint of a matrix A is determinant of A whole power n minus 1. This all I have given at the beginning. Now in place of n it is 3 and cross multiply 25 because I want determinant of A. So determinant of A n value is 3. So 3 minus 1 will be n value is 3. 3 minus 1 will be 2 is equal to 1 by 25. Taking square on both the sides, determinant of A will be plus or minus 1. Root of 25 will be 5. Option Bablu is correct. B. So we have problem smaller also. Okay. Come to this question. These are completely some of the things are there which is complete depending on the properties. If A and B are invertible matrices, then which of the following is not correct? And it's completely depending on your properties, how good you have learnt. They're saying adjoint of A is determinant of A into A inverse. For this, let's comment here only. Recall what is A inverse formula. It is 1 by determinant of A into adjoint of A, and determinant of A should not be equal to 0. Correct? Determinant of A should not be equal to 0. Now they have asked adjoint, cross multiply. As well as cross multiply, adjoint A is equal to determinant of A into A inverse. Yeah, I get this one. This is correct. But what they want, not correct. What about this? This, just see. This is, they have given in the other form. Let us write in the usual form. DET means determinant of what? Inverse of A is equal to, what is this? Determinant. And this inverse is out. Yeah, this is also known property. This is also true. Correct. Come to this. Yeah, this is a standard property. On this you also have problems and property. It is true. Correct. Whereas this one is incorrect. We don't have any as such rule. The inverse cannot be taken individual. Okay. So option D is incorrect. See how by using property we can solve. Now next, if A is a square matrix of order 3, so n is equal to 3, such that adjoint of the matrix A determinant is 81, we have to find determinant of A. We know that adjoint of the matrix A, adjoint of matrix A is determinant of A whole power n minus 1. So I can write this as determinant of A whole power n minus 1 is equal to 81. So determinant of A we have to find, and here n value is 3, so 3 minus 1 will be 2 is equal to 81. Therefore determinant of A will be plus or minus 9. Determinant of A is what? Plus or minus 9. Option D is correct. Kindly make a note. Okay, fine. Dear students, moving on to next question. If matrix A is a square matrix of order 3, determinant of A is 4, then determinant of A into adjoint A. Now actually we have two methods. One, we can treat this as matrix. Okay, let's discuss both the methods. Okay, coming to solution. Method number 1. As soon I see this, A is a matrix, adjoint is also a matrix. We know that if we have got product of two matrices, determinant of A into B will be determinant of A into determinant of B. A and adjoint A both are matrix. So I can write this one as determinant of A into determinant of adjoint of A. Determinant of A is given as 4. So I write 4. And what is determinant of adjoint of A? Determinant of A whole power n minus 1, where n is the order of the matrix and order is 3. So I can just substitute here 4 times of determinant of A is also 4. Then n is what? N is here 3. So 3 minus 1 will be 2. 4 square is 16. 16 into 4. 6 4s are 24. 4 are 5 6. 64. Option W is correct. This is method number 1. Method number 2, you see. It is just about how well you have learnt the properties and the results well. We also know what is A into adjoint A. It is determinant of A into identity matrix. A into adjoint is what? Determinant of A into identity matrix. And since we have got in the question determinant, I have just written the determinant as it is. Now here if you see, determinant of A is a scalar, I is a matrix. So recall what is determinant of scalar in a matrix. Determinant of a scalar in a matrix is k power n into determinant of A. So in place of k we have determinant of A. So it will come out and then it will raise to the power the order of the matrix, and determinant of, in place of A it is I, so determinant of identity matrix. Now A, determinant of A value is 4 and n is 3, and determinant of identity matrix we know it is 1. 4 cube is what? 64 only. That's what we have got. Both the ways I have thought. Come to the question number 38. If the determinant of the adjoint of a real matrix means all the entries are real number which we are dealing with, of order 3 is 25, if the determinant of adjoint of the determinant, they said, so determinant symbol of what? Adjoint of a matrix. Adjoint of a matrix of order 3 is 25 and order of this matrix is 3. Then the determinant of the inverse of the matrix, I want to find what is the determinant of its inverse. Determinant of its inverse. We know determinant of adjoint of A. Recall, have it in? Okay. Recall what is determinant of adjoint of a matrix A. It is determinant of A whole power n minus 1. So determinant of adjoint of A is determinant of A whole power n minus 1 is equal to 25. But what is n? 3. So here I can write determinant. For this I can write determinant of n value is 3. So 3 minus 1 will be 2 is equal to 25. Now since I want determinant of A inverse, first you take root on both the sides. Therefore, determinant of A will be plus or minus 5. But we want determinant of A inverse, which is same as 1 divided by determinant of A. So, it is 1 divided by plus or minus 5. What is 1 by 5? 0 0.2. So, plus by minus will be equal to numerator. 1 by 5 is 0 0.2. This is the value of determinant of A inverse. 0 0.2 plus or minus. Option D is correct. I hope this point is clear. Results are important to be memorized and applying them. See this question number 39. If A is a 3 by 3 non-singular, why they said non-singular? Only then the matrix will be invertible. Okay. If determinant of A is 3, then we have to find this. Fine. See, determinant of 2 times of A inverse. I have already given a property that K times of A, the whole inverse is 1 by K times of A inverse. So this will be, in place of scalar K, I have got 2. So I'll get 1 divided by 2 and A inverse as it is, then the determinant. Now from here, if you see carefully, we have got this as determinant of K into matrix A, which is K power n into determinant of A. In place of K, we have got half the scalar. So half, then power n. N is what? Order of the matrix, and it is 3 into determinant of A inverse. Okay. And this is also 1 by 2 cube is 8. And this is what? 1 by determinant of A. Determinant of A is 3. 8 into 3, 24. Option C is correct. Actually, the alternate means we could have thought in other way, that this one directly we could have written 2A the whole inverse. Let's make some space. See this. Determinant of 2A the whole inverse. Is same as 1 divided by 2A the determinant. Now from here, same old story. 2 K into A. K is 2. So I can write 1 divided by 2 power n. N is what? Order of the matrix is 3. So 2 cube into determinant of A. 2 cube is 8. And determinant of A is 3. 8 into 3, 24. 1 ones are 1 divided by 24. Same thing. Okay, option C is correct. See to this question. If A is a square matrix, then adjoint of A transpose minus adjoint of A the whole transpose is what they are asking. Recall the result which I gave you, that adjoint of A transpose is same as adjoint of A the whole transpose. As soon as I take to the left hand side, we are going to have adjoint of A transpose minus adjoint of A whole transpose is what? 0. So the value of this that here is 0. So option blue is correct. I hope it is clear. Kindly make a note. Okay. Yes. Let us move on to the next question. Question number 41. If K is a scalar, nothing but a real number, and I is a unit matrix of order 3, then adjoint of scalar into identity matrix, they have asked what is the value. See, I have already given a property that adjoint of a scalar with any matrix A is K power 2. Okay. In general, I will give K power n minus 1 into adjoint of a matrix A, where n is order of matrix A. Okay, I don't remember whether I gave n here or 2. If I have given 2 here, surely I have mentioned the order will be 3 here of the matrix. Now, using this result, in place of A we have identity matrix. So adjoint of K into identity matrix, In the question they have set order to be 3, so n is equal to 3 here. So put k, 3 minus 1 will be 2. Adjoint of identity. Adjoint of identity is again an identity matrix only. Adjoint of, okay, as a property you are going to remember. Similarly, adjoint of 0 matrix is 0 matrix only. So k square into I, there is option C. So option C is correct. Okay. Next, if A is a non-singular matrix of order 3 and adjoint of A plus A inverse is equal to 0, then determinant of A, they are asking us to find the value. Fine. See, going ahead with adjoint of a matrix A plus A inverse is given. And I want determinant of A. First, recall what is the formula of an A inverse. It is 1 divided by determinant of A into adjoint of A. Surely determinant of A should not be equal to 0, only that it is invertible. So it is solved for A inverse. So do one thing, solve for A inverse. If I want to solve for A inverse, it is addition of two terms. I have to transpose this to the right hand side. Then we will get A inverse is equal to minus adjoint of matrix A. Now if I compare, this is our equation number 1 and the formula on comparing 1 and 2. On comparing 1 and 2, we can see A inverse adjoint A, scalar is minus 1 here, and here it is 1 by determinant of A. So 1 by determinant of A is equal to minus 1, or taking reciprocal, I will get determinant of A is equal to minus 1 only. So determinant of A is minus 1. Option C is correct. Okay. Recording, no? Yeah. Next, question number 43. If A is a non-singular matrix of order 3, then adjoint of A cube. So I have taken so many problems where the benefit of knowing the properties should be understood. And you can see that in previous year, this type of question has come. Solution. They want us to find determinant of adjoint of A cube determinant. Recall, we know that determinant of adjoint of matrix A is determinant of A whole power n minus 1, where n is the order of the matrix A. So since here we have matrix A, so same matrix A is present here. Now here in place of matrix A, we have got A cube. So determinant of A cube whole power n minus 1. First, understand this. Since A is there, so A retained. Since A cube is there, so A cube. Remaining as it is after the formula. What is n? Order of the matrix A, and here it is given as 3. So n is equal to 3. Substitute here. Determinant of A cube whole power n is 3. 3 minus 1 will be 2. Recall law of exponents. What is A power m whole power n? It is A power m into n. Multiply the power 3 m into n. So here 3 into 2 is 6. So determinant of A whole power 3 2s are 6. Option D. I hope this is clear. Question number 44 is, if A is given, then A into adjoint A is A into adjoint A, they are asking. Now surely many will think of finding the adjoint A. Such shortcut method we can do. No. We can still get the answer without finding the adjoint. This is what, how well your concept is strong, how well your formulas, whatever is with your properties is strong. Recall, what is A into adjoint A? We know that A into adjoint A, this is from PUC class only, is same as adjoint A into A, which is what? Determinant of A into I. So this is a scalar matrix or a zero matrix provided determinant of A is 0. So if you see first option, it's not a scalar matrix. For scalar matrix, non-diagonal element should be 0 and diagonal element should be same. So here 5, 5, 5 is there, but these all are non-zero, therefore option A out. Option B and C are scalar matrix. Option D is a what? Null matrix. So it's only, I have to find only what? Determinant of A. As soon as I will get determinant of A, I will come to know among B, C, D, which is the answer. And along second row, we have got 0. So we'll expand along second row. So on expanding, I am writing this all thing for you to understand, because in online, whether you have followed or not, it's a question mark. So I am writing each and every step on expanding along second row, that is R2. See carefully, it is D here. So quadrilateral means diamond. So minus here, correct? So minus plus minus, so minus 0 off, nothing to worry. Then here plus 2. Leave this row and leave this column. So I'll get 1, 2, 3, 4. Then minus, nothing but minus into this minus plus 3. Leave this second row and third column. 1 minus 2, 3 minus 2. So 0, then 2 plus and minus, 1 into 4 is 4, then 3 2s are 6. Plus and minus, then plus 3 times of minus 2, minus minus plus 3 2s are 6. So we'll have this one to be minus 2 and this one to be plus 4. 2 into minus 2 will be minus 4 and 3 4s are 12. Nothing but we got 8. Determinant of A is 8. Therefore, this part, determinant of A into I will be 8 times of, since this is a 3 cross 3 matrix, matrix, that is identity matrix will be also, identity matrix will be also of order 3 cross 3. So 1 0 0 0 1 0 0 0 1. I'm just writing this. I could have directly said option C is correct, because determinant of A will decide which scalar matrix it is. Nothing but diagonal element will depend on determinant of A. Anyway, I'm just working out for more clarity. 8 into 1 is 8, then 0 0 0 8 0 0 0 8. So option C is correct. Kindly make a note. Dear students, now let us move on to some previous year question paper problems, and I have taken those problems which are a bit different compared to what we have solved. I mean to say, the problem which we have already discussed, the same type of questions also asked in the previous year Kcet question papers. I have taken here which are a bit different now. Now, question number 44 from previous year 2019. The constant term in the expression. The same question can be also asked. See, what do we make constant term? We know, see, you can see a variable x here. And it's a linear factors everywhere. So when I multiply, I'll get a polynomial. Don't forget, when I talk about constant, for example, minus 1 is a constant, whereas 2 is a coefficient. 2 is also a constant, but 2 is a constant multiple to a variable x. Therefore, to differentiate between a number multiplied to a variable and not multiplied to a variable, we use the word coefficient. We use the word coefficient. Coefficient means a constant multiplied to a variable. But since minus 1 is not multiplied to any variable, this minus 1, therefore we call it as a constant. So they want the constant term in this expansion. Either I can say constant term, or here is right, or term independent of x. Independent of x. This also I can say. Nothing but a term not involving x. Nothing but constant term. We have to find. Method number 1 will be expand this. Then you'll get a polynomial. Search for that term which is not a multiple of x. And that will be our answer. But it's too lengthy process. Then how to solve? Very simple. Common sense logic. I want that term which is free from x. Nothing but I don't want that term containing x. So what I will do, take the value of x to be 0. So what's the logic? I am not able to understand. No problem. Just see this. If I take a polynomial here, for example, a quadratic I have taken here, which is a constant term here. Okay, only I'll take a quadratic expression, which is the constant term here, c. So to get only the c, what I did is x is equal to 0. If I put, I'll get a into 0 square is 0, b into 0 is 0 plus c. So I'm going to get only what? C. So the constant term will not get affected when we take x is equal to 0. This logic I'm applying here. Put x equal to 0 in the determinant equation number 1. Then we are going to have, this will turn to be x is 0, right? X is 0. 3 into 0, 0. 0 plus 1 is 1. 2 into 0 is 0. 0 minus 1 is minus 1. 0 plus 2 is 2. Then 5, x is 0. 5 into 0, 0. 0 minus 1 is minus 1. 3 into 0, 0. 0 plus 2 is 2. 0 plus 1 is 1. 7 into 0 is 0. 0 minus 2 is minus 2. 3 into 0, 0, 0 plus 1 is 1, and 4 into 0 is 0, 0 minus 1 is minus 1. So now if I am going to evaluate, I am going to get the constant which is obtained after means after expanding this. I have just taken one example to make you clear, and I took a quadratic polynomial. Here you can see it is cubic actually. Just see 3x plus 1. Then we'll leave this one column. This will multiply as a quadratic, again a quadratic. Quadratic into linear will be a cubic. So I'll just give an example for you. And this will be true for whether it's a cubic, quadratic, biquadratic means power 4, then power 5, power 6, whatever. Same logic, okay? For to get constant term, put x is equal to 0. So get rid of these terms and get only constant. Now expand. We know how to expand plus, minus, plus. So 1 times of, leave the first one column, we'll get 2, 1. 1 minus 1, then minus minus plus 1. Then leave this 2 1 column. So we're going to have minus 1, 1, minus 2, minus 1. Then plus 2 times of, leave the first one, the third column. We get minus 1, 2, minus 2, 1. So this is plus minus, and here also plus minus. So 1 into 2 into minus 1 is minus 2, minus into plus is minus, 1 1s are 1, then plus 1 times of, minus to minus is plus, 1 1s are 1, then minus to minus is plus, 2 1s are 2, then plus 2 times of minus 1, then minus minus plus 2 2s are 4. So now simplify, this will be minus 3, this will be minus 3, this will be plus 3, and this will be minus 1 plus 4 will be 3. So we are going to have 1 into minus 3. So we what? 1 into minus 3 is minus 3. Then 1 into 3 is 3. Then 2 into 3 is 6. The value will be 0. This is a coincidence that we got a constant to be 0. It means what? In the polynomial when we expand, the constant term c value is what? 0. That's the meaning. Okay. It need not be always 0. So option A is correct. I hope this is clear. First make a note. I want to erase this. Okay. Dear students, moving on to question number 45. This question appeared in the year 2020 previous year Kcet. Question says, if f of x is given by this, then f of 2 value, f of 0, f of minus 1, f of 1, all they are saying the value is 0 among this, which is true. If you observe carefully, no, first in place of x either 2 it should be, or 0 it should be, or minus 1 or 1. So just carefully let us observe this. Question number 45 I am solving above. So f of x is equal to determinant of x cube minus x, a plus x, b plus x, x minus a, x square minus x, c plus x, followed by x minus b, x minus c, and here 0. Now we have to say among this which is correct. Many will think that one by one we have to evaluate, put this value and then expand. No, just see carefully. And that's what I'm saying. No, not only knowing the results and the properties important, how to apply them. The properties should be in fingertips with understanding. If you observe this, this is a determinant of order 3 by 3. I repeat, this is a determinant of order 3 by 3. And if you just see carefully, some important observation, watch. First thing, they are talking about value should be 0 only. Okay. Then you see, this is the diagonal element. Okay. Now you see corresponding this element. Plus a is there, minus a. Minus b is there, plus b. C is there, minus c. If I take x is equal to 0, see what happens. Then I will have f of 0 is equal to determinant of 0 cube minus 0, 0. A plus 0, a. B plus 0, b. 0 minus a, minus a. 0 square minus 0, 0. C plus 0 is c. 0 minus b, minus b. 0 minus c, minus c. Then 0 here. What is this? This is a skew symmetric determinant. This is a skew symmetric determinant of odd order. Odd order. To be specific, this is of order 3 by 3. Correct? 3 rows and 3 columns. So it is of order 3 cross 3. So of odd order 3, that is 3. And we know determinant of skew symmetric matrix of order 3 is always 0. So answer is, so when x is equal to f of 0, yes, just by careful observation we have got it. Okay. Now let us move on to the next question. Again I will erase this. I want to solve this problem first. Question number 45, 46. Kindly make a note. Now moving on to the next question, dear students. 2016 question 46 I have taken, came in the year 2016. They are saying if x, y, z are real number, then the value of determinant of this matrix A is. And if you see in the option, there are no new alphabets, they all are numbers. So coming to the solution of question number 46, listen carefully. They said determinant of this matrix A. So if I take the determinant here, it is 5 power x plus 5 power minus x the whole square, then 6 power x plus 6 power minus x the whole square, 7 power x plus 7 power minus x the whole square. Next 5x, I give some more space, it's a second column. 5 power x minus 5 power minus x the whole square, 6 power x minus 6 power minus x the whole square, 7 power x minus 7 power minus x the whole square, then 1, 1 and 1. We want to find the determinant value. Now either we can think of expanding, which is tedious job. Since they said x, y, z are some real number, let us take a particular value. And here, if you just see carefully, minus sign is there. And we know that whenever a power 0 is given, it's always here provided the base a is not equal to 0. It will be an easy calculation. And since minus 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 is there, as soon as I'm going to put x is equal to 0 in the determinant 1, I am going to get it to be, I'm not bothered about first column nor third column. I want only second column. See the second column here. Second column. Here x is 0. 5 power 0, 1. Minus 5 power minus 0 is again 1. The whole square. This also 6 power 0, 1. Minus 6 power minus 0, 1. The whole square. And lastly, 7 power 0, 1. Minus 7 power minus 0 also. 7 power minus 0 also, 1. Again, I am not, this is only I am bothered about second column, C2. 1 minus 1, 0, 0, 0. The one is what? 0. We know from the determinant, I repeat, we know from the determinant property that if all the element of a column or a row are zeros, then the value of the determinant is 0. Already I have discussed this properties at the beginning of the class. That's what. Make sure I said make a note one by one as I am covering the things. Okay. Sir, how you got this idea? I saw this minus. And since both the bases, see whatever the base will be, as soon as we are going in between the term negative and powers in the power is x, as soon as I take x equal to 0, I'll get what? 1 only now, over. And here we got 1 plus 1, 2, 2 square 4. So I'll get here 4, 4, 4. And this is 1, 1, 1, which is not going to be bothered for us. Okay, so for this question, option D is correct. Option D is correct. Let us take question number 47. This is a very interesting problem here. Doesn't mean that others are not interesting. All are interesting, good problem. But this type of question will ask our ability, the thinking capacity to be judged. So moving on to this problem, question number 47 came in the year 2022. Let us go for the solution. Question says if matrix A n is 1 minus n, n, 1 minus n, then determinant of A1 plus A2 up to 2021, and the options are given. Okay, we have to find each and every determinant. Fine. First you take matrix an is here. See this carefully. Whatever the index is there for A, the same index is used here. So when I want determinant of A1 plus determinant of A2 plus determinant of A3, like these, determinant of A2021. So in place of n we have 1, so substitute there. In place of here you put n is equal to 1, 1 minus 1 0, then here 1 1 1 minus 1 is 0. This part done. Now for here in place of n we have 2, so put n is equal to 2. What will get? Plus I wrote because I have plus here. 1 minus 2 minus 1, then here 2 2, 1 minus 2 minus 1, plus again for this I'll put n is equal to 3, correct? Because 3 is there here. 1 minus 3 minus 2, and here 3, then again 3, then again minus 2 here, plus moves on. In place of n we have here 2021. I'll put here 1 minus 2021 is minus 2020. Then here in place of n 2021. Again n is 2021. Okay, and here 1 minus 2021 will be minus 2020. Okay, I think it's not visible. Nothing wrong. I'm rewriting again. Okay, right from the left to most. Yes, put n is equal to 2021 here. So 1 minus 2021 will be minus 2020. Then here 2021. Then again n is this n 2021. 1 minus n is again minus 2020. Now expand this. Plus minus, what will you get here? 0 0 0 minus 1 into 1 1 square. Plus again plus minus minus plus 1 1 is 1. Then minus 2 2 is 4. Okay, so I'll write 2 square only. Forever, just see the pattern, will see. Then plus again plus minus to minus plus 2 2 is 4, so 2 square. Then minus 3 into 3 3 square. Like this it will go. And again here plus minus. When you multiply this, you will get minus plus 2020 whole square minus again multiply this 2021 the whole square. Just see the pattern. Observe the pattern carefully. Whatever terms we have got, no, see this. Don't forget minus plus 1 into 1 1 square. Okay, minus 1 square is being cancelled by the next term plus 1 square. Minus 2 square is cancelled by the next term plus 2 square. So it's very clear that if I have a term, the next term is cancelling. Again for this minus term, next positive term is cancelling. Again for this minus term, next positive term is cancelling. Correct? Now, so it also means that for this term, previous term is cancelling. Correct? Now, so it means here, so all this term will get cancelled. Coming to this last term, surely there will be a term before this which will cancel this also. But there is no term which can cancel this because next term should be there. Again I repeat, the negative term is cancelled by the next term. Again negative term is cancelled by the next term. Okay, here this negative term, there is no other term pending, means one more term I don't have. So my final answer be minus 2021 the whole square with negative out, and hence the answer is option C, Chalu. Yeah, the question was Chalu only. Okay, if you don't analyze properly, we think that's very difficult, sir. What is this? You didn't thought. We have to just have that come out of PUC, same question type not come. Whatever I've taken the questions, very good level I've taken. If you are the perfect in that, there is no chance that you can't get 55 plus. But your creativity should start. Okay. Workout. Simultaneously workout. Watch the video twice, thrice. Okay, for your own benefit. Kindly make a note. Dear students, let us proceed to the next problem. But before that, one note. Let us recall what is arithmetic progression. In short, write AP. Any progression in which common difference exists. For example, the general formula was A, then A plus D, then A plus 2D, then A plus 3D, and so on. Up to the last term. The last term is A plus n minus 1 into D. So you can see just I'm adding D to each term. A, if I add D here, A plus D, then again add here D. D plus D is 2D. Again add D here. I get 3D and moves on up to the last term. Now what we are saying, the property says is, Before that, how to know a given sequence is in arithmetic progression? Common difference should exist. For example, if I take one example here, 2, 6, 10, 14, and moves on. Here the first term is A1, second term is A2, third term is A3, and the fourth term is A4. Now the common difference to get, subtract the second term by its first term. So 6 minus 2, 4. Similarly, A3 minus A2. Always it is difference between a term and its previous term. Again a term, its previous term. So A3, 10. And A2 is 6. What's the difference? 4. And again you can see 10 plus 4 will be 14. Therefore, this is in arithmetic progression. So what we are saying is, coming to determinant, if any two rows, right here, if any two rows or columns are in arithmetic progression, then the value of the determinant is 0. So what is arithmetic progression? I have recalled here. Now just, this is direct. Take the difference of these two. 191 minus 190 is 1. Again 192 minus 1 is 1991 will be again 1. Again this difference what? 1. Again take this difference also. What difference? 1. So it is in arithmetic progression. So I can just comment that as two rows, as this is as two rows, two rows are in arithmetic progression, therefore the value of this determinant delta will be equal to what? 0. Option D is correct. Okay, come to this problem. Log is dead here and they want the value. I mean, many will think of expanding. No, we know from the property of logarithm, what is log m power k? This is same as k into log m. So this k will come left to the log. So the power will come left to the log. So you can see here left to the log. So here the power of, there is no power, nothing to worry. Here power is 1, nothing to worry. Here 2 it is, that can come left. Here 3 it is, it can come left. So I'll get log e. This will be 2 log e. Then this is 3 log e. Then again this 2 left to the log. All this 3 left to the log. 4 also left to the log. So 2 log e. 3 log e. 4 log e, and here also 3 log e, 4 log e, and here 5 log e. Now see carefully. One more result. What is log a? What is log a to the base a? It's always what? 1, provided these two logarithmic number a and the base both are same. And here whenever base is not mentioned, it's understood that the base is always e. So for all this log, the base is e, and the term which is written here is also e. So log e will be 1. So I will be having, here 1. This is 1. But 1 into 2 is 2. Then again, here 1 into 3 is 3. Then here 2, 3, 4, and 3, 4, 5. Check it out. Is it in common? Is it in AP? For that, check the common difference. Subtract this. 2 minus 1, 2 minus 1, 1. 3 minus 2, 1. 4 minus 3, 1. So common difference is 1 here. Again check here also. 3 minus 4, 1. 4 minus 3, 1. 5 minus 4, 1. So here also common difference is 1. Therefore the value of the determinant is 0. Option A is correct. I hope this is clear. Okay. Now dear students, let us move on to the next question. Question says if if A is a square matrix given and A inverse is also given, nothing but inverse of A, inverse of this A is here. Then find the value of x. There are two ways. One, you can multiply these two matrix and you should get identity, equate to identity matrix and get the value of x. Other is, since this is A inverse, from here, find A inverse. What's the formula? 1 by determinant of A into adjoint of A, where the adjoint means determinant of A should not be equal to 0. Now from here, determinant of A, how are you going to get? Plus minus 2 into x, 2x. Then minus 1 into 0 is 0. So minus 0. This is our first part. Into adjoint of the matrix. How to get adjoint? X staying the diagonal element. This will be x here, then 2 here. And here plus 1 will change to minus 1, 0. Whether like minus 0 plus 0 plus 0, there are no difference. Now simplify. 1 by 2x minus 0 is 2x. 1 by 2x. Then x here, minus 1, then 0, then 2. Multiply scalar in. Vice, here you can see there is no scalar out. Therefore, A inverse is 1 by 2x into x. So x into 1 is x divided by 2x. 1 into minus 1 is minus 1 divided by 2x. 1 into 0 is 0. 1 into 2 is 2 divided by 2x. Now I can equate whichever you want. You can see that x by got cancelled half. You are getting first element to be what? Half. That is where, yeah, present. Now, so as you can see, now when I equate this minus half x, okay, this x in denominator, be careful. So minus half x when I compare with this, so I'll get minus 1 by 2 x is equal to 1 by 6. 2 1s are 2 3s are, so minus 1 by x is equal to 1 by 3. Cross multiply, x is equal to minus 3. That is in option A. Okay, again you can see here also 2 and half will get cancelled. 1 by x is equal to 1 by 6, equal matrix only. Okay, now let us move on this problem. First make a note. I'm going to erase that side. Okay, see carefully. Okay, let's just try to complete here only. Suppose A is any 3 by 3 non-singular matrix and A minus 3i into A plus 5i is equal to 0 matrix, where I is of order 3 and 0 matrix is also of order 3. See, this need not be specified. It's understood that, see, when A is of order 3 by 3 and you are subtracting with the identity matrix, for subtraction we know that addition and subtraction can happen with that matrix whose orders are same. Since this is 3 by 3, this should be also 3 by 3. And when you are simplifying and getting a 0 matrix, that should be also what, 3 by 3 only. If I alpha into A plus beta into A inverse is equal to identity, then what is alpha plus beta value they are asking. Coming to the solution, there is no matrix given to us. They are given one condition here. From this we have to achieve. Now for that, let us consider this A minus 3i into A minus 5i is equal to 0. A into A will be A square. A into minus 5i will be minus 5. A into I is ai. Minus plus to plus is minus. 3i into A, 3ia. Minus into minus is plus. 3 5s are 15. I into I is I square is equal to 0. We know that A into identity or identity into A matrix is always what? The matrix A itself. So from here we can just write it here that A square minus A into I is A. So 5 times of A minus 3. Yeah, I into A is also A. Then don't forget I square. What is I power n? It is always I only, where n is a natural number. You can raise whatever power for identity matrix, you will get back identity matrix only. So 15, oh, one mistake here. I into A is A. Then 15 I square is I is equal to 0. A square minus 5a and minus 3a is minus 8a plus 15i is equal to 0. We want, see in this expression we have got A inverse. So pre-multiply by A inverse on both the sides. So A inverse into A square minus 8A inverse into A plus 15A inverse into I is equal to A inverse into 0 matrix. A inverse into A square will be A minus A inverse into A will be I. We know the property. Then recall here, what is A inverse into A? Identity matrix. And what is A into identity matrix? Will get what? A itself, the same matrix. Since I have got A inverse, I'll get back what? A inverse itself. And A into 0 matrix always what? 0 matrix itself. So A inverse into 0 will be 0 matrix. Now just arrange. You want identity matrix in the right hand side. Okay, remaining in left hand side. Identity matrix we can transpose. So we get A plus 15A inverse is equal to 8I. Now you see here it is 4. If at all you want to get alpha and beta value which are multiple of matrix A and A inverse, you have to equate this one with that matrix. But to equate I multiple the scalar should be 4, but here I've got 8. So divide by 2. So if I divide by 2, I'll get half into this is matrix A. Mind it. Then plus 15 by 2 A inverse. Then 8 by 2 I. This will be 4. This is my equation number 2. When I see equation number 2, this one. And equation number 1. This I will take as equation number 1. Now comparing, since I want alpha plus beta value, I want alpha value. Alpha is multiple of A. What is multiple of A? Half. So alpha is equal to half. Beta is multiple of A inverse. So on comparing, beta will be here. Multiple of A inverse is 15 by 2. How I got? On comparing 1 and 2. On comparing 1 and 2. So they wanted the value of alpha plus beta. Add them. Alpha plus beta will be half plus 15 by 2. 2 is the LCM. 15 plus 1 is 16. 2 ones are 2 8s are. So value is 8. Option D is correct. Kindly make a note. Dear students, let's move on to next question. See, I have taken two matrix problem, and this question says if matrix A is given, then what is A square? And options are given. Similarly, what is A cube for 3 by 3 matrix, and which option is going to be true? Method number 1 will be finding A square, and then from each of the option finding the values and matching with this, time consuming. At least this you can do somehow. But for 3 by 3, actually I have taken from this NCERT only, where you have an exercise problem for 5 marks. Okay. Now you know yourself that for 5 marks how lengthy it was. Minimum 7 minutes you are going to take, 5 to 7 minutes. But for CET on an average we have 1 minute. Now just say I'm going to give one concept. Listen carefully. Before we go ahead, I would like to discuss one small concept as a note I will take here. Trace. T-R-A-C-E. Trace. Trace is defined as sum of diagonal elements. Sum of diagonal elements. And it is denoted by TRA of whichever matrix we are talking about. Okay. So this we call trace. Just sum of the diagonal elements of the matrix, square matrix A. Now here, whenever you have a 2 by 2 matrix, the equation is given by, the formula is A square minus trace of the matrix A into matrix A plus determinant of A into identity matrix equal to 0. Now since the determinant is involved, I have not taken this one in matrices chapter regarding no. Yeah. Now let us go ahead. See how easily you can frame. Trace is the sum of the diagonal elements. So I'll take this as equation number 1. From here, for this matrix, trace of the matrix A is addition of the diagonal element, that is 2 minus 4 is minus 2. Then determinant of A, that is 2, 3, 7 minus 4 plus minus. So 2 into minus 4 is minus 8. Then minus 7 3s are 21. We will get minus 29. Now all these I'm going to put here. Whatever I've got, put in equation number 1. Therefore A square minus Trace is trace. This trace is here -2. This minus from the formula, and again here -2 times of matrix A. Determinant of A is -29 into matrix I is equal to 0. Now here A square minus minus plus 2A, then minus 29 I is equal to 0. Actually, I could have given in the option, okay, this with some sign change. My motive was also, let us suppose they ask A square, from then what to do. If this, in place of giving A square is equal to question mark, then all the option contains A square, E and matrix I. As soon as you get, you can compare and get the answer. I just went one more step ahead. What if they have asked A square? Okay, transpose all the terms to the right. A square is equal to minus 2A plus 29 times of I. So this part is our solution. See the option minus 2A plus 29I, that is in option C. Option Chalu is correct. Okay. Now let us come to 3 cross 3. It's how we are going to go ahead for this. For 3 cross 3, and again, sign you should remember that here you have got the formula which I give you. Yeah, this formula. Be careful. Plus sign of A square is plus, then trace is minus, then plus. You can just remember as determinant sign, no? Plus, minus, plus. Okay. Now for this, since order is 3, so you'll have degree 3 A cube. The formula will be this. So you are going to note this formula as it is a very important note here as well. So see carefully. It will be A cube minus trace of the matrix A into A square plus sum of the cofactors of the diagonal element, that is A11 plus A22 plus A33 into A minus determinant of A into I is equal to 0. This will be the formula. And again the sign is no problem. Plus minus plus minus. Here we have got one extra, that is sum of the terms is there, but it is of cofactors of the diagonal element. Now let us go one by one. Coming to this matrix A solution, starts from here. This note to be remembered, to be memorized by you. See, trace, that is sum of the diagonal element. 1 plus 2 plus 3. 1 plus 2 plus 3 is 6. Next, I want cofactors. Okay, cofactors. A11 diagonal element. Leave. This is 1. So leave the first row and first column. These are the minus. And here no need to think I'm worried about to multiply cofactor, because don't forget the cofactor formula is Aij is equal to minus 1 power I plus j into Mij. I plus j, if it is even, then minus 1 power even is positive, and that is in the index. You can see 1 plus 1 2, 2 plus 2 4, 3 plus 3, okay, 9. For the last it is, sorry, 3 plus 3 6. I repeat, 1 plus 1 2, 2 plus 2 4, 3 plus 3 6, all are even. So minus 1 power even is what? Positive only. So no need to be bothered about writing minus 1 or plus 1. It will be always positive. Okay, so I can just directly evaluate. So 2 3 are 6 minus 0, answer is 6. Then A22, how to get A22? Yeah, this element, leave the second row and second column. So 1 2 2 3, 1 2 2 3. So plus minus 3 1s are 3, minus 2 2s are 4, answer is minus 1 here. A33, third one, third column, 1 0 0 2. So plus minus 1 into 2 is 2, minus 0, it is 2. And determinant of E also we want. And before that, what's the sum of this? A11 plus A22 plus A33 will be 6 minus 1 plus 2. 6 minus 1 will be 5. 5 plus 2 will be 7. Next, determinant of A. Determinant of A we can get from here. That is 1 0 2 0 2 1 203. 102, 021, 203. This is plus, then minus, then plus. 1 times of 2 3s are 6 minus 1, then minus 0, then plus 2 times of 0 minus 4. Here it is a minus and then 6. So 6 minus 4 2s are 8. I will get minus 2. Therefore, put all the values, put all these values. So, yeah, trace is here 2, equation number 2, this is 3, and this is 4. So, put 2, 3, and 4 back in 1. Put 2, 3, and 4 in 1. Then our equation number 1 will change to a cube minus trace of a is 6 into a square. Then sum of this, we got a 7 times of a, then minus determinant of a. Determinant of a is minus 2. Minus into minus will be plus 2 times of I is equal to 0. We have been asked a cube. Transfer the remainder on the other side. Therefore, we are going to have a cube is equal to 6a square minus 7a minus 2i. So the value, therefore the answer is a cube is equal to 6a square minus 7a minus 2i. That is then option C. Chalu. So I have covered both 3 cross 3 and 2 cross 2. 2 cross 2 we can expect. So far 3 cross 3 has not come, but just I have explained so that it will be remembered and should not be too difficult job to get. Okay, kindly make a note. Dear students, let us move on to the next question. Question 55. Let A be given matrix A square is equal to 25 determinant square. Find the mod alpha value. It's not that we have not solved this above question previously, but here I would like to again recall, if below the principal diagonal element, that is 5 alpha 5, if all the elements are 0, how we are going to evaluate the determinant? And here it is given here determinant solution, determinant of A square is equal to 25. Again recalling that should not multiply A twice and then take the determinant. We know that determinant of A power n is same as determinant of A whole power n. So this will be determinant of A the whole square is equal to 25. Taking square on both the sides, we are going to have determinant of A is equal to plus or minus 5. Now I want determinant of A. Since with respect to diagonal, the below all the elements are 0, therefore the determinant value will be product of the diagonals. So product of the diagonals. So 5 into alpha into 5. 5 into alpha into 5 is equal to plus or minus 5. So you can see here, since the multiplication, 1 5 will get cancelled here. So I'll get 5 alpha is equal to plus or minus 1. Cross multiply. Alpha will be plus or minus 1 by 5. They want mod of alpha, so take modulus. Mod will convert negative to positive, and negative, I repeat, mod will convert negative to positive, and positive remains positive only. So mod of this will be only plus 1 by 5, which is in option blue. B is correct. Moving on to the next question, evaluate. It's a permutation problem. Factorial notation is there, but when you see the options, very clear that we are not explaining. For example, what is 5 factorial? We know it is 5 into 4 into 3 into 2 into 1, which is 120 after multiplication. We are not going to expand. See, this will be 120, this will be 720, this will be 5040. Very huge. We have one formula for this, but see the pattern here. See the pattern here. The formula. See the pattern. The formulas I'm going to give you. If I got n factorial, next is n plus 1 factorial, next is n plus 2 factorial. So it's consecutive term. After n plus 1, after n plus 1, n plus 2. Then whatever term is there here, same term here also. N plus 1 factorial. Okay, again, as soon as n plus 1 is there, next term n plus 2 factorial, which is same as here. Next is n plus 3 factorial. After that, here again whatever is there here, same, n plus 2 factorial, then again n plus 3 factorial, then n plus 4 factorial. See the pattern here with respect to diagonal. Okay, first n, after n plus 1, n plus 2. Then whatever is there here, n plus 1, then n plus 2, n plus 3. Again, whatever there is here, same term, then n plus 3, n plus 4. It's a consecutive term. Then the answer will be 2 times of product of the first row. Product of the first row. That is 2 times of n factorial into n plus 1 factorial into n plus 2 factorial. Okay, and I close the bracket. So now you see this should be, so you can see the same pattern, 5, then 6, 7, then 6 here, then 7, 8, again 7 is here, then 7 is here, 7, 8, 9. Then the answer is 2 times of the first row. What's that? 5 factorial into 6 factorial into 7 factorial, which is there in which option? Option blue. So option B is correct. I taught you how to find inverse of a 3 by 3 matrix. It's not there. 3 by 3 matrix. How are we going to go for a special case? This is a diagonal matrix. For diagonal matrix, there is no need to go for the usual method which I gave you. For diagonal, one note I will give you. If A is a diagonal matrix, not only of order 3 cross, it can be of any order. Like this, moves on. The last row. In place of writing like this, no, we write diagonal matrix to be like this. R, if the other way of writing diagonal matrix, D-I-A-G, diag, only the diagonal element. Which are the diagonal element? A1, A2, up to AN. So surely here the diagonal elements not be equal to 0. If any one of the diagonal elements are 0 in diagonal matrix, inverse does not exist because determinant of that will be 0. So diagonal of A1, then A2, then A3, like that up to AN. So in place of writing such a lengthy expression, we write small like this. Okay, where since diag says diagonal elements are this, then the inverse of diagonal element is given by, just you have to raise power -1 for each of the term. So A1 minus power -1, then A2 power -1, A3 power -1, like this, AN power -1. That's it. So now you see this, having this knowledge, this A inverse will be, since the diagonal matrix, we're talking about inverse. Okay, I'll write it here only. So the solution of the problem will be A inverse, just raise power -1 for all the diagonal elements. So 2 power -1, 3 power -1, 4 power -1, then zeros as it is. This is also same as 2 power -1 is 1 by 2, then 0, 0, 0. 3 power -1 is 1 by 3. Then 0, then 0, 0, and here this is 1 by 3, and 4 power -1 is 1 by 4. That is the option blue. I want you to remember one note. What? If in diagonal matrix, if in a diagonal matrix any diagonal element is 0, then inverse does not exist. Why inverse does not exist? For example, you see here, if this element is 0, diagonal element 0, 0, 0, and expand along third row, you can see yourself the determinant will be 0, and we know inverse exists only for non-singular matrix. Determinant should not be equal to 0. So if in diagonal matrix any diagonal element is 0, then inverse does not exist as determinant of A will be equal to 0. Fine, kindly make a note. Okay, dear students, now let us move on to the last concept, that is solution of system of linear equations. Solution of system of linear equations. Yeah, you got it right. 5 markers which you had. Now there are some other things to be discussed here, not just finding the value of x, y, z. Okay. First, understand here, we want to find the solution of system of linear equations. Now coming to our PUC and CET, we have got 3 equations, 3 unknowns maximum. So if I just write in general, so let's consider the system of equation. So if I've got a1x plus b1y plus c1z is equal to d1. The second equation, a2x plus b2y plus c2z is equal to d2. Then a3x plus b3y plus c3z is equal to d3. So we have got 3 equation and all are linear equation. When do we say linear equation, the degree of the variable x, y, z, as you can see, it is 1. Okay, and geometrically this equation represents a plane, and if I only consider this with this 2 constant, then it's a straight line. Okay, now we are going to put this in the form of a matrix. So matrix A is equal to, matrix A is a coefficient matrix. This we call coefficient matrix. This is going to take care of all the coefficient of the variable x, y, z. So it is here a1, then here b1, then here c1, and here it is a2, b2, c2, and lastly here a3, then b3, and here c3. And then we have a column matrix x whose variables are x, y, z. So why are in the form of column, you'll come to know. And the right hand side, you can see constant. Even if the left hand side, we are going to transpose. You have to make sure before writing this format, let us first complete. Matrix B is the constant right hand side, d1, d2, and d3. When you're writing this, it should be, make sure before you write A, B, and X matrix, that all the variable x, y, z should be in the left hand side and the right hand side should be a constant. Why do we so? See carefully. When I'm going to multiply Ax, I'm going equal to B, I'll get back the same matrix. Just see, A into X, row versus column, correct? Multiply this row and this column. A1 into X plus B1 into Y plus C1 into Z. You got the first equation is equal to B, is equal to first D1. Yeah, D1. Next, second column. Sorry, second this column there. A2 into X, A2 X, B2 into Y, B2 Y, then C2 into Z is equal to D2. Then A3X plus B3Y plus C3Z is equal to D3. Okay, this will be a constant matrix. This is a variable matrix, the unknown. And here our target is to find the solution, nothing but x, y, z value capital X. Since I want to find capital X, I'm going to take inverse on both the sides. So pre-multiply A inverse on both the sides. When I'm saying pre-multiply A inverse both the sides, we are surely assuming that determinant of A is not equal to 0. Nothing but the coefficient matrix is non-singular matrix. So when I pre-multiply A inverse into A into X is equal to A inverse into B. What is A inverse into A? It is identity matrix into X is equal to A inverse into B. A inverse into A is equal to identity. What is identity matrix into A? We get back the same matrix A itself. So I into X is X is equal to A inverse into B. Wait, don't forget. What is the formula to find A inverse? 1 by determinant of A into adjoint of A, where determinant of A should not be equal to 0. So whenever we are going to go with this approach, where you are going to have this we call matrix method. This method we call matrix method. Whatever we have just discussed here, I'll write it here. Matrix method of finding the value. This matrix is known as matrix method. And here you are going to get unique solution because inverse exists, and unique solution exists as determinant of A is not equal to 0. Now the problem is, if determinant of A is 0, we may not have a solution or we may have a solution. Okay, but before I go ahead to that part, just I want to comment some of the things here. See, this system which I have taken now, we can discuss in two categories, homogeneous and non-homogeneous. Let I just put a word here. When I say homogeneous, it's not homogeneous differential equation. In system of linear equation, we have got homogeneous. When I say homogeneous system of linear equation, and you should understand why the word linear we understood degrees 1. Why system? More than one equation, no? So system. So when it says a homogeneous linear differential equation, the constant should be always 0. That is, the matrix B is always 0, which implies D1 is equal to 0, D2 is also 0, and D3 all should be equal to 0. Then you say homogeneous. Then what about non-homogeneous? Before that, just some space. Non-homogeneous system of linear equation. Now coming to non-homogeneous system of linear equation, the constant matrix, at least constant matrix B should not be equal to 0. When I say B should not be equal to 0, recall the definition of 0 matrix, all the elements should be 0. So even if one element is not 0, any one of di is not equal to 0. I is 1, 2, 3. I'm not writing till n because I'm taking 3 by 3. We can generalize the same thing for n cross n, but anyway we don't require. Maximum over is 3 equations, 3 unknowns. Okay. Now here, try to understand. As soon as I say constant is 0, this system of equation will be this: a1x plus b1y plus c1z is equal to 0. Next, a2x plus b2y plus c2z is equal to 0. Lastly, a3x plus b3y plus c3z is equal to 0. Just see carefully. For a while, no, you think in terms of two variable, two equation. Two variable, when I say it is only this, equal to this. What is this? Equation of a line. And since constant is absent, the line will pass through the origin. Even this 3 plane. Now if I talk about this entire left hand side, then this equation represents plane. What's a plane? It's a surface satisfying condition that if I take any 2 point, line joining on this 2 point, we should also lie on the same surface, that we call a plane. The word plane is not used in PUC class, now in CET class, because in the chapter 3-dimensional geometry we had one topic known as planes that was removed after COVID-19. So there we will derive that. We used to derive that general equation as we have got ax plus by plus c equal to 0. Ax plus by plus c equal to 0 represent equation of a line. Similarly, this is for line. Similarly, general equation of form ax plus by plus cz plus d is equal to 0 represent equation of a plane in 3D. Okay, but it's not there now. But I want you to understand what is happening here. This is a plane. Now, coming to line, whenever constant is absent, the line will pass through the origin. This is x-axis and y-axis. Line will pass through the origin. So the line will be passing through the origin. When the line is passing through the origin, understand here carefully that the solution is always 0, 0. What is solution? Point of intersection of this both the lines. And here we talk about consistent and inconsistent. When it's a consistent, solution should exist. But I comment here also. When do we say a system is consistent? For consistent, solution should exist. Solution exist. Inconsistent, solution does not exist. Solution does not exist. Now we should understand here what is the solution. The values of x, y, z, which will satisfy this equation. Whenever determinant is not equal to 0, we get unique solution. In this case, it's always consistent. As soon we came to know determinant of A is non-zero, nothing but a non-singular matrix, surely solution exists. That to unique solution. And as soon as it's a homogeneous, always we are going to have a solution, and the solution, say it passes to the origin 0, 0 in 2 dimension, in 3 dimension 0, 0, 0. So whenever this homogeneous equation is there, this implies x equal to 0, y equal to 0, and z is equal to 0 are trivial solution. We call always we are going to have a solution for homogeneous, and this we call are called trivial solution. Trivial solution. I think but obvious. Now the question mark will be, can we have other than trivial solution? Okay, and coming to non-homogeneous, we don't have as such. As you can see, if d1, d2, d3, even if any one is not equal to 0, if you put x, y, z equal to 0, left will be 0, but right will not be equal to 0. Now we have got one more point to be discussed here, having discussed homogeneous, non-homogeneous. If determinant of A is not equal to 0, we have got unique solution. What if determinant of A is equal to 0? Let I just comment it here. If determinant of A is equal to 0, many have got a false assumption that it is inconsistent. We don't have any solution. No, it is wrong. It is wrong. First, you make a note of this. That I discuss in clear. Okay, with clarity, I'll discuss separately. First, make a note. Okay, dear students, now understand this. I was talking about if determinant of A is 0, what can we think of? Whether solution exists, whether it is consistent or inconsistent. For that, let I consider equation of line. As we know, equation of line, if I take equation of line, when I talk about in 2D, there are 3 behavior of a line, pair of line. Those 3 behavior in 2 dimension I'm talking about. The line can be parallel. This is line L1, and the other line is here L2. This first one is a case of parallel lines. We can have one more case. The line can be coincident. Line L1 here, and the other line is overlapping on this, and it is L2. Third case is the lines L2 and L1 can intersect at a point. So this is coincident lines. Coincident lines. And this is intersecting lines. These are the 3 behaviors. Many will think, sir, we didn't spoke about perpendicular. What about the case of perpendicular? Perpendicular is a special case of intersecting. When the angle between the line L1 L2 is 90 degree, then we say it is perpendicular. So as soon as I say intersecting lines, perpendicular case is also covered. Okay. Now let us say that the line L1 equation is a1x plus b1y is equal to c1, and the line L2 equation is a2x plus b2y is equal to c2. Pair of line I've got. So now when I talk about this parallel lines, Recall, now I'm going to your school days. In school days, recall whenever two lines are parallel, you used to take always this coefficient of x and y, and that should be proportional, nothing but a1 by a2 should be equal to b1 by b2, and that should not be equal to c1 by c2. For coincident, all should be proportional. A1 by a2 should be equal to b1 by b2 should be equal to c1 by c2. And for intersecting line, these two ratios, that is a1 by a2, should not be equal to b1 by b2. It may or may not be equal to c1 by c2, no problem. This is the condition for the pair of lines to be parallel, coincident, and coincident when I say overlapping. You can see overlapping. And here you should also, and here it is intersecting. You should also understand for parallel lines, since there is no intersection, we talk about solution here. It is a point of intersection. Geometrically, it is point of intersection between pair of lines given to us. And then plane, if it have a three equation, three unknowns. After we have a three variables, it's a three linear variable. When we have an equation containing three linear variable, it's a equation of plane, as I discussed here. For 2, it is line. Now see here, there is no solution because the lines are not intersecting. So for this case, no solution. For this case, infinitely many solution. If you just see, let I just take the other color. See here, this part, there is infinitely many solution. Many solution. They are overlapping. So and here, so it is, I can say infinitely many solution. Infinitely many solution. Since no solution, this is inconsistent. A system is said to be consistent if solution exists. Whether it is one or more, no problem. Here infinitely many solutions, so it is consistent. System is consistent. Here unique solution will get. Unique solution. Therefore it is consistent. Now see carefully. Determinant of A is equal to 0. See carefully now. What is the matrix here for this? It is x and y multiple coefficient a1 b1, then a2 b2. Take the determinant of this plus minus. Now what you will get? a1 b2 minus a2 b1. Correct? Come here. Cross multiply this. A1, if I cross multiply this, what I'm going to get? Cross multiply A1 B2 is equal to this one will be B1 A2. Transpose this. A1 B2 minus A2 B1 is equal to 0. I'm not bothered about is equal to 0 presently. Presently I'm bothered about, just see this left hand side. Whatever we have got the ratio, that is the determinant value. See, A1 B2 minus A2 B1. So what I'm trying to say is, this ratio, when I'm going to simplify, I am going to get determinant of A. This also give determinant of A, and this also give determinant of A. Here, now listen carefully. Since I had equality, I got equal to 0. So this will give you determinant of A to be equal to 0. And it's inconsistent. Again, the same I have got here. I'm not bothered about constant. This one. This will give you again the same thing. And this will also give you what? Determinant of A equal to 0 only. Whereas, you see this one. This is same as, again, this one only thing is here, equality is there, here it is not equal to. So when I'm going to solve, I'll get what? Not equal here and not equal here. So I'll get determinant of A not equal to 0. What I'm trying to make you understand, that whenever determinant of A is equal to 0, yes, it is consistent and it is unique solution. But as soon determinant of A is equal to 0, many people will comment that it is inconsistent, which is false. Determinant of A equal to 0 can have infinitely many solution or no solution. It can be inconsistent or consistent. Just getting determinant of A equal to 0 You cannot comment that system don't have a solution or have a solution. You can only say that I have to check. But as soon determinant of A is not equal to 0, you can always comment that unique solution exists. Definitely not only solution, unique solution, nothing but is going to just intersect at a point. I hope this point is clear. And that's what in homogeneous, surely I'm going to have one point of intersection definitely, because it passes to the origin. Okay. So that's what we call trivial solution there. Now the same logic is also there for 3 dimension. Nothing but as soon as Z comes, 3 equation, 3 unknowns. Then what is the remedy? Remedy for this, and I erase this side. The remedy for this, how to know from here, we are going to have how many, means whether solution exists or no. For that, what we are going to do is, case as soon determinant of A is equal to 0, there are 2 things to be understood. That's what I commented here. Either no solution, this implies inconsistent, or solution exists, not just solution, many solution exist. Many solution exist implies consistent. Now how to decide this? We are under 2 thoughts how to decide this. For that, what we are going to do is find the adjoint of the given matrix A and multiply with matrix B. So what is happening here? Very simple. When we had this formula, no, x is equal to A inverse into B, for this determinant of A should not be equal to 0. So for example, if I take determinant of A inverse what? Adjoint of A divided by determinant of A, just to follow. If I just cross multiply this, now from here scenario we can get clarified. Now see from here. Now from here, 2 things. For both, if determinant of A is equal to 0. So if I put, I hope I have not taken anywhere 1. Okay, 1. If determinant of A is equal to 0, so left hand side will be what? 0. Here also same. If determinant of A is equal to 0, again the left hand side will be 0. Now, when you're finding adjoint A into B, and let us suppose that even adjoint of A into B, after you have performed how to find adjoint, transfer of cofactors, I've given a shortcut, but I'm going to discuss one more method, okay? So adjoint of A into B, if it is equal to 0, this implies we will have many solutions. So how can you comment? Very simple. When this is 0 and this is also 0, 0 equal to 0, so infinitely many solutions. Okay. Whereas second scenario, left hand side is 0, nothing but this one. Wait, if determinant of 0, left hand side is 0 of equation 1. Here also left hand side 0 of equation number 1. But A adjoint of A into matrix B is not equal to 0. If this is not equal to 0, simply we get non-zero matrix. When you are getting non-zero matrix, equal, now this side is what? Non-zero matrix. But here, since determinant of A is 0, 0 into any matrix is what? 0 only. So 0 and here it is non-zero. So left hand side, but okay, but this but right hand side, let us write here this hand, and here this right hand side is not equal to 0. This implies no solution. No solution, and hence inconsistent. Here, and hence consistent. I just gave this one so that with respect to PUC you are be thorough. Now I just try to take some problems, and I will give you Kramer's rule also, by which it will be still more better. Kindly make a note. We are almost to an end of this chapter. Kindly make a note. Okay, dear students, before we go for 3 variables and 3 equation, let us first talk about the pair of lines. So the question will be like this, no? Check the check the consistency of the following linear systems. I could have also taken as an MCQ question, but let us save some time. So I will take 3 question. First, 2x plus 3y is equal to, let's say, 6, and 2, okay, I'll take some other number here, 4x plus 6y is equal to 8. Okay, this is the first question. Second, 2x plus 3y is equal to 6 and 4x plus 6y is equal to 12. And third question, 2x plus 3y is equal to 6 and let's suppose x plus 2y is equal to 6. We have to comment whether it's consistent or not. For finding the solution from PUC. Anyway, if you want, I can solve. See, then way for PUC, you can go for method of substitution, elimination method, or cross multiplication method. But here my objective is, without going to adjoint of A into B, then you have to multiply, then you have to check. In place of that, just in no time you can get the answer. This represents pair of lines because we have a 2 equation, 2 unknowns. So whether the solution exists or not, it just depends on parallel line, coincident line, or intersecting line. For that, we want only x multiple and y multiple. X multiple is 2 here, divided by x multiple is 4 here. Y multiple is 3 here and divided by 6, and the constant. Check, are they proportional? 2 ones are, 2 twos are, 3 ones are, 3 twos are. Oh, half equal to half. But this is 2 what? 3s are, 2 4s are. This is not equal. Half is equal to half, but not equal to 3 by 4. This implies given line is, given pair of lines parallel. Given pair, recalling no? Given pair of lines are what? Parallel. This implies no solution. Since no solution, this implies it is inconsistent. Inconsistent system. When you say consistent, solution should exist, either finite or infinite, no problem. Moving on to next. Now again for this also same, x multiple 2 and here 4, y multiple 3 and 6 and here 6, 12. Simplify. 2 ones are, 2 twos are, 3 ones are, 3 twos are, 6 ones are, 6 twos are, all are equal to half. All are equal to half. Nothing but they are proportional. Since proportional, here the lines were parallel, due to which there was no solution. Here the lines are coincident, overlapping. Since they are overlapping, we have, this implies given pair of lines are coincident and hence many solution. Whether I say many solution or infinitely many solution, both are the same and hence consistent. One last thing here, just see this. So you can see how much time we can save talking about consistent and inconsistent by using school days concept. That's what no school chale hum. Now coming to this, x multiple 2, again here 1, y multiple is 3 and here 2. Are they equal? 3 by 2 and 2 by 1. No, they are not equal. When they are not equal, we are least bothered about the concept whether it's same or not. And here this implies lines are intersecting. Lines given, okay, both given pair of lines, let's give the same. Given pair of lines are intersecting. Given pair of lines are intersecting, and this implies it is consistent as we have, I said intersecting, so one line is here, one more line is somewhere here. Here it is the solution. So consistent as we have unique solution. Unique solution. Fine. So this way you can go ahead. Now let I do one thing. Let I also show you how to solve. If suppose they ask you to find the x and y value, no, very simple. In the option they'll be giving x and y value. Just put it here, the one which will satisfy this for answer. That's it. Otherwise, elimination method, substitution method, cross multiplication method, and this here matrix method. Whichever you want, you can go ahead. Now make a note of this. Dear students, now let us move on to the condition for homogeneous to have a non-trivial solution. So, condition for homogeneous system of linear equation to have infinitely many solutions, or infinitely many. When I say here infinitely many, we mean to say other than trivial solution. Where's the black? Infinitely many, that is non-trivial solution, trivial, other than what? 0, 0, 0. So I'm discussing this with respect to 3 equation. Let us consider we have got a system of homogeneous equation a1x plus b1y plus c1z is equal to 0. Then a2x plus b2y plus c2z is equal to 0, and a3x plus b3y plus c3z is equal to 0. So this is a homogeneous because all the constants are 0. Should not happen, no, that you have kept some constant in the left hand side and then you are commenting that right hand side is 0. No. All the variable x, y, z should be in the left hand side and all the constants should be in the right hand side, and then you have to check whether any one of the constant is non-zero. Any one of the constant is non-zero. Even if one is 0, then it is homogeneous. Sorry, even if one is non-zero, it is non-homogeneous. If all are 0, then it is homogeneous. Okay. Now the condition on this is, if I take the determinant of coefficient matrix, that should be equal to 0. Who is the coefficient matrix? X, Y, Z multiple. Here A1, then B1 and C1. Here A2, B2, C2. Then here A3, B3, C3. The coefficient matrix determinant should be equal to 0. If it is not equal to 0, unique solution. Okay. There's always a determinant of coefficient matrix is not equal to 0, it's unique solution. Now on this one, question number 16, and here, solve about 57, 58, 59. I discussed that consistency, that we can take as 58, 59 and 60. Sorry, 58, 7, 58, 59, this is 60. Find the value of lambda for which the system of equations given here has non-trivial solution. Lambda value they have asked here, and that lambda you can see here. And it's homogeneous because constants are 0. The answer in right hand side is 0, constants are 0. So for that, take the determinant here. X multiple 2, y multiple 3, z multiple minus 2. So 2, 3 minus 2. Then here 2 minus 1, 3. Lastly 7 lambda minus 1. Check it out. 2, 3 minus 2, 2 minus 1, 3, 7 lambda minus 1 is equal to 0. Find the value of lambda here. It's very simple now. Plus, minus, plus, simple calculation. 2 times of minus 1, 3, then lambda minus 1, then minus 3 times of 2, 3, 7 minus 1. Then plus into minus 2 times of, leave the first row and the third column. 2 minus 1, 7 lambda is equal to 0. Now 2 times of, this is plus and minus, so minus minus plus, then minus 3 lambda, then minus 3 times of again plus minus 2 into minus 1 is minus 2, minus 7 3s are 21, then minus 2 times of again plus minus 2 into lambda is 2 lambda, minus minus plus 7 is equal to 0. Simplify. 2 1s are 2, minus 2 3s are 6 lambda, then here this will be minus 23. So minus minus plus, 3 3s are 9, 3 2s are 6. 2 into minus 2 is 4, then lambda minus plus minus 2 sevens are 14 is equal to 0. Minus 6 lambda minus 4 lambda is minus 10 lambda, and 69 minus 14, okay, 2 minus 14 is minus 12. 69 minus 12 will give you 57. Since I want lambda value transpose this from here, we will get 10 lambda is equal to 57, or we are going to have lambda is equal to 57 by 10. 57 by 10 is there in which option? Check it out. So 57 by 10 is there in option blue. Okay, for this value of lambda, if I put lambda is equal to 57 by 10, then I'm going to have infinitely many solutions for this system of homogeneous equation. Now one question can be also framed. One question can be framed. For what value? Same, okay, everything same. In place of saying has non-trivial solution, I'll ask for what value of lambda the above homogeneous system of equation has. No, okay, they said non-trivial. No, has trivial solution. Trivial solution. What could be the answer? Think. Nothing to simplify. For trivial, non-trivial solution, determinant should be equal to 0. For trivial, it should be determinant should be equal to 0. If it is equal to 0, I repeat. For what? Non-trivial solution, determinant should be equal to 0. For trivial, it should not be equal to 0. Not equal to 0, not equal to 0. So answer is what? Lambda should not be equal to 57 by 10. Whichever. So we got this value for what? Non-trivial, nothing but other than 0, 0, 0. Now, if the question is what? Has trivial solution, then I should write not equal to 0, then I'll get this. So then I can comment that whenever lambda is other than 57 by 10 for this system of homogeneous equation, I get only trivial solution. Okay, trivial solution, unique solution, x equal to y equal to z, all are zeros. Okay, fine. Now let us move on. Now let us move on to the next problem. Solve, and this you can see is non-homogeneous because constant is not 0, all are not 0, and here options are given. Method number 1 is x is equal to a inverse into b. Sir, you thought one shortcut method will go. No. What you are going to do, take this value, put in all the equation, the option satisfying all the equation is my answer. The option even not satisfying one equation is not my answer. Okay, and this is what I said, no, that previous 3 cases which I did for checking the consistency, unique solution, either matrix method or what school is elimination, cross multiplication method you can do. But in the exam, if they ask, they will give you the option. No, you can just put the option, get the answer. That way I'm going to do now. And when we are going to take, for example, option A, if it is going good, if option A is not going to satisfy the first equation, option A will not be taken for second, not for third equation. Reason: I want a solution that is satisfied by all. Even if it is not satisfied by one, then that particular x, y, and z value is not a solution for this entire system. I want like this. If I talk about plane, okay, line. If I talk about this, when I say it is unique solution, all have got common point of intersection. Similarly, plane. Now, since this is plane, now something like this I can draw. This one plane, this one more plane, and this one more plane. Not aeroplane. Not aeroplane. Come on, let's take one by one. So option A, if I take and substitute here, x is equal to, I'll take b here to have some space. So I'll do one thing. I'll first erase this to make it clear. First make a note. Okay, I'll number this as equation number 1, equation number 2, and equation number 3. So option A I'm beginning with. So option A value is x value is 2, y value is -6, and z value is 3. If I put in equation number 1, so x value 3 into 2 plus 4 into -6 plus 7 into 3. So simplifying this, 3 2s are 6 minus 24 plus 7 3s are 21. So that 24, yeah, fine. So if I add this 2, I'll get 27 minus 24 will be 3. 3 not equal to 0. See, we have got, I mean to say, when I substitute here, I should get equal to 4, not equal to 0. I should get equal to 4. I didn't got equal to 4. Therefore, x is equal to 2 minus 6 and 3 are not the solution for this system of equation. You may say, sir, you have only checked for first one, not for second, not for third. Then how can you comment? I said unique solution. This solution should be satisfied by all the three simultaneously. Even if one is disobeying, no need to check the remaining. Now let us go for, so option A out. Now I'll take option B. In option B, we have x equal to 6, y equal to 3, and z is equal to minus 2. Put in 1. So we have 3 into 6 plus 4 into 3 plus 7 into minus 2. 6 is 18, 4 3 is 12, minus 14. Again, this itself is a 4 plus 12 will be 16. Na? Yeah, 16, but I want 4, not equal to 4. So option W also gone. Now take C. X is equal to 1, y equal to 1, and z is equal to 2. If I substitute in equation number 1, for this, no. Actually, at least here we got positive, negative, positive, 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 negative. Here all are positive. And you see the equation here, left hand side also contains only positive term. And this, when I put here 3 1s are 3 itself, plus 4 itself more than 4, surely this will not satisfy. Without working also, by using common sense, we can say it will not satisfy equation number 1. So option C is out. So surely option D should be correct. Why, sir? Without working, how can you say in CET how many should be correct? Anyone? No. ABCD or ABC is already out. Anyway, let us check. Okay, let us check option D. X is equal to 1, y is equal to 2, and z is equal to minus 1. If it was an exam, surely after knowing ABC is not satisfying, I could have just said option D and I could have marked. But here only for you people to understand better, I am working out. Okay, so put it here in equation number 1. So 3 into 1, okay, then plus 4 into 2 minus, okay, plus 7 into minus 1 in place of x, y, z. So what I'm getting here, 3 plus 4 to the 8, plus into minus 7. So here 8 minus 7 is 1. So 3 plus 1 is 4. Yeah, equal to right hand side. As soon you get this, doesn't mean that it's a solution. You have to check the remaining. For this problem, I can say it is a solution because already ABC are out. But as I said, for you to have a clarity, let us suppose that this was the first option, and as soon this is satisfying, what we could have did, we could have taken this that option, first option itself, gone for the second equation. So I'm going to say now put x is equal to 1, y is equal to 2, and z is equal to minus 1 in equation number 2. When I put it here, I should get minus 3 the right hand side. So 2 into 1 minus 2 plus 3 into minus 1. 2 1s are 2, minus 2, yeah, minus 3, minus 2 plus 2 will get cancelled, minus 3 is equal to right hand side. It is satisfying first also, second also. Now take the last. Again, let's put here, put x is equal to 1, y is equal to 2, and z is equal to minus 1 in equation number 3. When I put here, I should get minus 8. So x is equal to 1, then plus 2 times of 2, then minus 3, z is minus 1. So we will get here 1 here. 1, 2 2s are 4 plus 3. So I will get 8. Yeah, right hand side. Just for you to have clarity, I have did. Otherwise, as soon as I came to know here, it is satisfying because ABC is already wrong, not satisfying, not a correct answer. So I could have directly went. But let us suppose that this was the first option and was satisfied by first equation. Then the same option we take for second also and third also. I repeat, first option Let us suppose this was the first option. It's satisfied here. Then I'll check the second equation for the same first option. If it is satisfying for this, then I'll go for the third one. If it is not satisfying for this, I'll not go for the third one. I'll change the option. I'll go to option number 2 and do the same. As soon one equation is not satisfying, reject that solution, because ultimately it is a solution for all the three. Okay. And one more thing, when I'm saying solution, how many solutions do we have? Many will say, sir, 3. How? Sir, 1, 2, 3. X equal to 1, y equal to 2, and z equal to -1. 3 solution. No. This is one solution. Unique one. This 3 triplet. What? X comma y comma z, that is 1, 2, -1 together forms a solution for this system of equation. This is only one solution. Don't count this 1, 2, 3. It's a triplet. One solution. Triplet means what? Together 1, 2, 3. 3 we call triplet. If you have got 2, ordered pair. Chapter relations and functions. Kindly make a note. Okay. Dear students, now having discussed for a while, having discussed the non-trivial solution for homogeneous system of equation and also the matrix method for system of linear equation, non-homogeneous, correct? As soon as I say homogeneous, always trivial solution, x equal to 0, y equal to 0 and z equal to 0 is always there. And one more thing, when I was talking about system of linear equation by matrix method, as soon the coefficient matrix capital A determinant is 0. First, if I take not equal to 0, the coefficient matrix A determinant, if I take not equal to 0, then I have a unique solution. But if it is equal to 0, we have got two cases. It may have no solution or it may have infinitely many solutions. This is with respect to non-homogeneous system of equation. But as soon as it is homogeneous, nothing but the constant matrix B, all the element of matrix B, the constant column matrix should be 0. All the elements should be 0. Then as soon determinant of A, nothing but coefficient matrix A is 0, surely it's going to have only one conclusion, that it has infinitely many solutions. Okay, there is no question about no solution for homogeneous, because all are going to pass through the origin. I hope this point is clear. Now coming to non-homogeneous, one more method we are going to learn, that's known as Kramer's rule. That will be very benefit. Now it will be very benefit for us. Kramer's rule. It's very simple, and from this we can also go for unique solution, no solution, and many solution for 3 equation 3 unknown. For 2 equation 2 unknown, already I have discussed. Pair of line we can take school this concept and we can get it. Now Kramer's rule. Let us consider system of equation. Let us suppose we have got a1x, recording no, b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, then a3x plus b3y plus c3z is equal to d3. We have got non-homogeneous system of linear equation. Now what this Kramer's rule says, no, take delta as the coefficient matrix of x, means coefficient matrix A, we take as delta. So here x multiple a1, y multiple b1 and z multiple c1. Here it is a2, b2, c2. And lastly a3, b3, c3. Then delta suffix x means c. So delta suffix x is equal to, you should see here that the first column, which is a1, a2, a3, are the coefficient of x, x, x. So this we are going to replace by the constant in the right hand side, that is d1, d2, d3. Second column and third column no change. That's the reason for you to understand and remember that we are replacing the first column, which is the coefficient of x, is being replaced by the constant, so I given delta x. Similarly, I give delta y. It means coefficient of y. that is there, b1, that is b1, b2, b3, that is here, y multiple are being replaced by the constant in the right hand side, d1, d2, d3. Whereas with respect to this, the first column no change, the third column also no change. Similarly, delta z, the third, see delta z about, so z multiples are c1, c2, c3, that is third column will be changed by the constant, that is d1, d2, d3. Now first column as it is, then second column entry as it is. Now here, coming to first part, from here, first part, if at all I want unique solution, same coefficient matrix A determinant should be not equal to 0, that is this delta should not be equal to 0, only then unique solution. And how to find unique solution? Very simple. To find x value, delta x determinant, nothing but this, should be divided by delta. Similarly, y is given by delta suffix y by delta, and lastly z is given by delta suffix z by delta. Repeated I'm saying delta suffix x, y and z to make you understand. It's just a notation. I could have taken 1, 2 and 3 here. Since I wrote xo, you remember that coefficient of x is replaced by constant in the first column, coefficient of y is replaced by the constant in the second column, coefficient of the z is being replaced by constant d's by in third column. That's the reason I've taken like that. Okay, and many will have a doubt, so how to remember delta x by delta or delta by delta x? Very simple. Think as delta got cancelled x, delta got cancelled y. Just for understanding I'm saying, you can't cancel that. Okay, this is for unique solution. Now comes, what about no solution? No solution. First, for no solution, what should happen is this itself you cross multiply for all. I'll get here x into delta is equal to delta x. This one will be y into delta is equal to suffix delta y, z into delta, okay, delta suffix z. When I say no solution, I'll do one thing. I will give this heading no solution below, because from here two cases will rise at once. We can complete. One is no solution, other is infinitely many solution. See, whether I say infinitely many solution, or just many solution, both are same. Okay, now listen carefully. For both, same thing, that delta should be equal to 0, same as we had determinant case, no, for matrix method. Now see carefully here, when I say no solution, see carefully. If delta is 0, nothing but the left hand side you can see delta, this will be 0, and at least one of delta x or delta y or delta z should not be equal to 0. That is, either delta x should not be equal to 0, or delta y should not be equal to 0, or if any one of them is not equal to 0 but delta is 0, then there is no solution. So what's the logic here? Very simple. If delta is 0, for example, let us suppose that delta is 0 and delta y is not equal to 0. If delta is 0, 0 and anything is what? 0. So the left hand side will be 0, and delta y is not equal to 0. So 0 and not equal to 0 will be what? Here I got 0. Here I got 0. That is here equal to, I got here some non-zero number like 7. Non-zero number like 7. 0 is not equal to 7. Yes or no? It is going to contradict. That's the reason it is no solution. Okay, fine. Whereas for infinitely many solution, when delta is 0, del x, del y and del z all should be 0, and del x should be 0. I will use the word and here. Del y should be 0 and del z. And means for each I am saying. Here if any one also not equal to 0, then it is what? No solution. If all are equal to 0, delta is also 0, then it's a many solution. So with this, let us try to take a problem on what? No solution or many solution. This one I thought I will not take a problem to solve. I'll do one thing. I'll take one problem on this also. Let us suppose in examination, in place of asking x, y, z, they ask any one of them. Then matrix method will be too lengthy. Correct? So we'll take a problem on this as well. Make a note of this. Okay, dear students. Now on Kramer's rule, I have taken one problem. Question says find y for the following system. See, if it is x, y, and z given, by using the option we can get the answer that I have taught you. But let us suppose in place of x, y, z they have asked either x or y or z. Matrix method will be too difficult, and you cannot go with the option, because if you put this, for example, y value, you will put y value, then you have to find z and x value. Correct? For that y, you will have a unique x and z, time consuming it is. Then let us go with the Kramer's rule, how to deal with. Simple. Since I want y, don't forget y is given by delta suffix y divided by delta. Just find this. Delta is, I'll take this as equation number 1. Delta I want. Delta is what? Coefficient matrix determinant. That is x, y, z multiple. Here 2, y multiple minus 1, z multiple minus 1. And here it is 3, 1, minus 1. 1, 1, minus 1. So here plus, minus, plus. Plus into plus is plus, so plus 2. Leave the first row and first column. So you are going to have 1, minus 1, 1, minus 1. Minus, minus, plus, plus 1 here. Leave the first row and second column. 3 minus 1, 1 minus 1. Then plus into minus, minus, minus 1. Leave the first row and the third column. 3, 1, 1, 1. Now let us expand. Plus, minus, plus, minus, plus, minus. So we are going to have 2 times of 1 into minus 1 is minus 1, minus, minus, plus, plus into 1 is 1. Then plus of 3 into minus 1 is minus 3, minus minus is plus, 1 1s are 1. This is 3. Then minus 1 times of 3 into 1 is 3, minus 1 into 1 is 1. 3 minus 1 is 2, minus 3 plus 1 is minus 2, minus 1 plus 1 is anyway 0. 0 into 2 is 0. Plus into minus, minus, minus into plus, minus. So we got delta to be minus 4. Delta is minus 4. Now delta y. How to get delta y? See carefully. What we said, delta y means we have to replace the coefficient of y by the constant. Coefficient of y is in second column. So second column, first column no change. So 2, 3, 1 as it is. Then the second column is replaced by the constant 773, that is in right hand side, 773, and then the third column as it is, that is minus 1, minus 1, minus 1. Now simplify. Plus, minus, plus 2 times of leave the first row and first column, 7 minus 1, 3 minus 1, then minus 7 times of, if I leave this, and then minus 1 times of 3, 7, 1, 3. Plus minus, and plus minus. So 2 times of minus 7, minus minus plus, 3 1s are 3, cross multiplication. Then minus 7 of again cross multiplication, minus 3 minus 1 is plus 1. Then minus 1 of 9 minus 7. This will be 2, minus 2, and here minus 4. So 2 4s are 8, minus minus plus 7 2s are 14, minus 2. Minus 8 minus 2 will be minus 10, so I'll get 4 here. Delta y we got 4. Therefore, the value of y is given by delta suffix y divided by delta suffix y we have got as 4, as you can see here, and delta we have got minus 4. Substitute. What is 4 by minus 4? We'll get minus 1. Therefore, y value is minus 1. Minus 1 is there in option blue. Okay, similarly, let us suppose they ask x. So, till here same. In place of the first column 2, 3, 1, you have to replace by the constant. 2, 3 are coefficient of x. Similarly, I want y. Formula mean to say z. It will be delta z by delta. So again, in this, when you are going to work out for delta z, in place of this third column, you should have 7, 7, 3, and you will find it. Okay, kindly make it out. Let us solve the next problem. Okay, now it is more on the problem. Question says the value of lambda and mu for which the system of linear equations given by this has infinitely many solutions. Infinitely many solutions. So recall for this, first delta should be equal to 0. I'll take the solution from here only. Okay. So let us start here only. Okay. Delta coefficient of xyz matrix delta determinant 1, 1, 1, 1, 2, 3, 1, 3 lambda. This should be for 0. Next, see carefully. See carefully what I do. Comment here. Delta x if I want to write, I have replaced the first column by the constant 2, 5 mu, and this 2 column no change. 1, 2, 3, 1, 3 lambda. Similarly, delta y will be from this second column 1, 2, 3 will be replaced by 2, 5 mu. No change in the rest. For infinite many solution, delta x, delta y, and delta z, all the three should be equal to 0. Then delta z. Again, this first and second column no change. Whereas the third column 1, 3 lambda will be replaced by 2, 5 mu. Now understand what I want to say. For infinite many solution, this condition should hold good. Now if I solve this, you can see only one unknown. I can get lambda value. Okay, solve for this determinant plus minus plus. So 1 into, leave the first row and first column, will get 2, 3, 3 lambda. Then minus 1 times of, leave the first row, second column, 1, 3, 1 lambda. Then plus 1, leave the first one, third column, 1, 2, 1, 3 is equal to 0. So here we are going to have plus minus, plus minus, plus minus. So 1 times of 2 into lambda is 2 lambda, minus 3 3s are 9. Then minus 1 into lambda is lambda minus 3, plus 1, 3 minus 2 is equal to 0. 1 into this will be 2 lambda minus 9, then minus lambda plus 3, then 3 minus 2 is 1, 1 into 1 is 1. Then 2 lambda and minus lambda is the lambda, minus 9 plus 3 will be minus 6, plus 1 will be 5, minus 5, or lambda is equal to plus 5. So lambda is equal to 5 there in option B and C. So surely we have to find the mu value also. Now listen carefully. You can take any one of this. But if I take this and this, problem is lambda is also there. Again I have to put and then simplify. It is better I can directly solve this only and get the answer. So at least now I hope I can skip this one step and directly I can jump here. Okay, first time I'm doing so. So hope so you will follow. 2 into mu is 2 mu, minus 5 3s are 15, minus 1 times of, I'll leave the first one and second column, so we'll get mu minus 5 plus 2 times of, leave the first one and third column, 3 minus 2 is equal to 0. So here 2 mu minus 15 to 1 is 2 mu minus 15, then minus into plus is minus mu, minus minus is plus 5, 3 minus 2 is 1, 1 into 2 is 2. 2 mu minus mu is mu, minus 15 plus 5 will be minus 10, minus 10 plus 2 will be minus 8, or mu is equal to 8. Mu is equal to 8 and lambda equal to 5. So they said lambda and mu, and they use the word respectively. Nothing but first value is lambda, second value is mu in all the options. So C is correct. Option C. Why I said like this? I could have directly said 5, 8. Option C is correct. Let us suppose let us suppose this option they gave as 8 and 5. Then it's very important to understand whether this or this. Since the word respectively is given, it means it is this lambda, this option A, B, C, D, the first value that is here 8 or 6, 5, 5, 4 are possible values for lambda. Similarly, 8, 7, visible no? 8, 7, 8, 9 are possible values of mu. So whenever they give 2, be with this order. Since lambda is first, or in each of the option, first values are possible values of lambda. Similarly, second values are possible values of mu. Okay, so I hope this is clear. Now here it's no. Let us suppose note. Why again take one more question. They said here infinitely many solution. Let us suppose that question was no solution. If question is no solution, then what? Surely then also delta should be equal to 0 only. If delta is not equal to 0, you will get unique solution. Then this part is same. So I'll get lambda is equal to 5. And for no solution, recall at least one of them should be not equal to 0. So again, delta z not equal to 0. On solving, what I will get? Mu not equal to 8. I hope this is clear. So kindly make a note. Now we'll take one last concept, elementary transformation. Make a note. Dear students, let us move on to the next question. I know as soon as I've seen trigonometry, values 0 and we have got some range. Many will think option E is correct because so far, whichever the problem we have solved, it is always a number, one particular number, not a range. See, if trigonometry in this problem, if sign get cancelled, it may be this. But if it is not getting cancelled, then it will be one among this. Okay, so let's try to simplify. Plus, minus, plus. I have to evaluate determinant. And now that again parallel line is understood, right? 1 into, leave this one column, we'll get 1 minus sine theta, and 1. Minus plus is minus sine theta. Leave this row and column, then we'll get, I'll do one thing, I'm not taken from the left to most. Nothing wrong, space is not sufficient. I don't know why I didn't start from the left corner. Determinant of A is equal to 1 into, leave this one column, we'll get 1 minus sine theta 1. Minus plus is minus sine theta, leave this row and column, we'll get minus sine theta minus 1 and 1. Yeah, then plus 1, leave this one column, we'll get minus sine theta minus 1 and here minus sine theta. Before we go ahead, just check have written correctly. Yeah, row this column. Yeah, minus sine plus sine minus 1 plus 1. Yes. Yes, now it is expand. Plus minus 1 into, yeah, 1 into 1 minus to minus is plus, sine to sine is sine square theta minus sine theta, plus into minus multiply here, so minus sine theta minus to minus plus sine theta, so here both they get cancelled. Then plus 1 times of minus plus sine to sine is sine square theta. Then minus plus what? 1 ones are 1. So this is anyway got cancelled. 0 I have got here. 0 into minus is 0. So 1 into this is 1. So 1 plus sine square theta plus 1 into this is same. So I'll get again sine square theta plus 1. 1 plus 1 is 2. Sine square theta plus sine square theta will be 2 times of sine square theta. This is the determinant of A. That is not in the option. In the option they are talking about the range. So at least for basic trigonometric function sine, we should know the range. Sine range, we know that The range of sign lies between where to where? Recall -1 to 1 close interval. Then we have to get this term here. So see one by one. First you see 2 plus 2 sine square theta. First I want square. So on squaring both the sides. On squaring both the sides. When I say, many will say square of -1 is 1. Square of +1 is also 1. So sine square is only 1. No. See number line. We have -1 to 1. This set of values 0 is here. So from here till here we have values, including them, because equality is there. As soon I said square, all this negative number on squaring become what? Positive only. Everybody will come to this region. So as soon I went for squaring, sine square theta will be between 0 to 1. How, sir? See, for example, here minus 0.5 square it, you will get 0.625. Sorry, 0.25, not 625. Correct? It will go to this side only. Okay, next. See, I obtained this. I'm trying to obtain this term. Now I have got 2. So multiply divided by 2. Whenever you multiply or divide by a positive number, inequality will not change. We know that. So multiply by 2. Okay, here the word writing both sides are correct. Just on squaring we should write, because we don't have 2 sides. We have 3, 1, 2, 3. We can't call side also. So 2 into 0 is 0. That's not equal to 2 times of sine square theta, less or equal to 2 ones are 2. Then add 2. So add 2. When you add, inequality will not change. So 0 plus 2 less or equal to 2 plus 2 sine square theta less or equal to 2 plus 2. 0 plus 2 is 2 less or equal to 2 plus 2 sine square 2 theta less or equal to 2 plus 2 is 4. Therefore, this is what? Determinant. So 2 is less or equal to determinant of A less or equal to 4, or I can say that determinant of 4, I mean to say determinant of A is lying between close interval 2, 4. Why close interval? Equality is there, values are taken, which is then option D. See, as soon, actually speaking, no, as soon we got this without any working, we could have said this only, because sine square is present here. Sine is always bounded with equality. If it was something like tan square, tan theta, etc., then we have a chance of open interval. Okay, but I solved it first for you to understand. And who knows, in place of this 2 option, if I could have given something like 2, 3 close interval, then surely you have to solve. No? Okay, fine. Kindly make a note. Okay, dear students, let us move on to the last concept, that is on elementary transformation. Elementary transformation. Here, actually, this was there in the old syllabus, but to 2023, one question came. Yeah, here it is. So I just thought not to take a risk. I'll just cover this concept as well by taking these 2 problems, but first we'll discuss the concept. The first one is, we can, okay, along row, okay, I'm talking about rows, Ri, nothing but R stand for row, I stand for which row number, ith row, and jth row can be exchanged. But when you exchange, this sign will change. When you exchange, sign SIGN, sign of the determinant changes. This is 65, this is 66. Okay. One more is, we can multiply any row by a scalar, where k is a non-zero scalar. The same row I'm multiplying, but as soon as I multiply the scalar, no, that row will change. So Ri dash I have taken. Lastly, I can add any two rows Ri with a scalar multiple Rj, but again scalar is not equal to 0. And after adding two rows with a scalar multiple, I will get a new row. That row I have taken as Ri dash. Okay, I mean to say Ri and Rj is performed. I am performing on Ri. That Ri has changed, right? So Ri dash. The same operation we have got in columns also. Exchange of two columns, again sign will change. So Ci and Cj. Then you can multiply with scalar column also. So Ci dash. So k into Ci, where k is a non-zero scalar. K is any real number but not 0. Sir, why not 0? Very simple. Now, if you take a scalar to be 0 and if you multiply a row or column, each and every element of a row or a column becomes 0. If all the rows of a column or a row is 0, recall the value is what? 0. Okay, so every time you get 0 only. Recalling, no? Yes. And similarly for column wise also, we can have addition of two columns. When you're adding any two columns with a scalar, the determinant value remains same. Here the value will remain same for this and for this. Value of determinant remains same. Determinant remains same. Whereas here, no, that we have got no determinant of k into a same as k power n into the determinant of a. So as soon as I multiply the scalar, the value of the determinant, the value of the given determinant will change by k times of the given determinant. Okay, same thing here. Okay, so even for this sign will change. Now here question says let omega not equal to 1 be a cube root of unity. Cube root of unity in the chapter matrices in detail I have discussed, and then I have taken the problem. I think then we took the omega power 70 something like that, and I have discussed in detail how it is represented, etc. Okay, so now here they are saying if omega is cube root of unity, then and a is equal to this, then find the inverse they are asking. Now see, to find the inverse, determinant of a should not be equal to 0. So first let us find the determinant of a. Determinant of a is equal to, we have 1 omega square omega square 1 omega square 1 omega. Now since I know the result, what 1 plus omega square, sum of the 1 omega square is 0. Can you see here 1 omega square, here also omega square 1 and omega square 1 omega. So I can add all the columns. I think we're applying this operation. Sorry, yeah. Here taken to explain 2. It can be all the 3 columns also. So C1 plus C2 plus C3, and I can store in any one of the columns as C1 dash. Now here I see this is like computer, whatever the operation we do. This is the operation. After you perform the operation, you have to store the value. Correct? That storing is in C1 dash. Now at 1 plus omega square, I will add 1 plus omega square, and I'm going to store the value in C1 dash. So I'm going to get 1 plus omega square. Here's omega square 1. Add 1 plus omega square. Lastly again omega square 1 and omega I can add. I'm writing in order. And second column no change. Third column also no change. Now since we know 1 plus omega square is 0, the first column will become 0 0 0, whereas second column no change, third column no change. Recall the properties of determinant. We have learned that in a determinant, if all the elements of a column or all the elements of a row are zeros, then the value of the determinant is 0. So why 0? In this determinant, what has happened? All elements of column C1 are zeros. That's the reason determinant value is 0. Since determinant of A is 0, this implies inverse does not exist. Don't forget, for a matrix to have inverse table, nothing but inverse to exist, its determinant should not be equal to 0. Therefore, option D is correct. Inverse does not exist. Question number 66. The value of this determinant, let I erase this. The value of this determinant. I know as soon as you see trigonometry, sir, trigonometry, this we can't leave trigonometry. As soon as you start calculus, you will see continuity, differentiability, limits, integration, application of integration, followed by before that application of derivatives, definite integral, differential equations. Without trigonometry, I think minimum we can expect 20 to 25 questions, or at least 15 to 20 questions from calculus. Okay. Anyway, after this chapter, I'll go for sets, then relation function, then I'll go for trigonometry functions. But at least now, whatever the result I'm giving, make sure learn that. Now here we have to evaluate. This came in 2023, but there was a printing mistake here. It is 14 degree measures 24 degree. Okay, that's why I corrected. I'm taking tan 135 degree. Recall tan 135 degree. Allied angle concept. Tan of 180 degree minus 45 degree will give you 135 degree. So this 180 is same as 2 into 90. Recall allied angle concept. Whenever the 90 multiple is even number, trigonometric function remain the same. So tan will remain tan. And we have 45 degree, and 180 minus theta lies in second quadrant. In second quadrant, only sine and cosecant are positive, remaining for a negative. So I'm going to have a negative sign here. Tan 45 is minus. Okay, tan 45 is 1. Tan 45 degree is 1, and with minus sign as it is. So now this, if I substitute sine square 24 degree, then sine square 66 degree, tan 45 is minus 1. Again here tan 45 is minus 1, here also minus 1. Then sine square 66 degree, then sine square 24 degree, sine square 24 degree, sine square 66 degree. Now see carefully. We know from trigonometric one important result. What? Sine square A plus sine square B is equal to 1. Sir, sine square theta plus cos square theta is 1. No sir, this is also 1, provided A plus B, sum of these two angle is 90 degree, or actually saying odd multiple of pi by 2. Okay, even it is 2 for 270 degree also. Okay, or in short, odd multiple of pi by 2. Now see carefully. Can you sum this? 24 degree and 66 degree. Someone sum it up. What is 24 degree plus 66 degree? This will be what? 90 degree. Okay, it means if I sum these two, similarly sum this and this, sum this two also, I will get sum of the to be equal to what? 1. So what I will do, add column 1, column 2 and column 3 and store in first column. See carefully what's happening. Sine square 24 degree plus sine square 66 degree minus 1. First column, second column, third column. Column wise you have to add. This is the first column, second column, third column. So all the column element here added. Now here also. Sine square 66 degree. I'll first write this so that the thing is clear for us, and then minus 1 as it is. Again the last column, minus 1, then plus sine square 24 degree, then sine square 66 degree. Remaining no change. Okay, so first you let us write it. Yes. Now if I erase this side, this problem erase. I have taken. Now see. See carefully. Now see carefully. What is the sum of the angle? 90 degree. So by using this, since sum of the angle 90 degree, sine square plus sine square is 1. So this entire value is 1 minus this one. Again, sine square 66 degree, or plus is here, my mistake, yeah, plus it is. So it will be 1 minus 1. Again here also minus 1 as it is. Then sum of this, oh the place I forgot, sorry. Yeah, you can see now, I'm adding all. So sine square 24 degree and sine square 66 degree, again plus 1. And second column as it is, third column as it is. But here most important to observe is, first column entry all are 0. As soon all the element of a row or a columns are 0, the value is what? 0. Again the reason same, C1, all elements are zeros. Therefore the answer is option D. Kindly make a note. Yes. Dear students, totally we have solved around 66 problems with all the concept in detail. So with this chapter determinants come to an end. Make sure give your 100%, be dedicated, study well, work hard, and in the link of in the description, the link of matrices is also provided. I hope you have gone through that. Okay, and after this chapter we are going to go ahead with chapter sets. Okay, so I'm going to first PUC sets, because I have to go for relations and functions. Without relations and functions, I mean to say without sets, we can't do anything about relations and functions. Relations and functions are important for trigonometric functions. Why trigonometric required? For inverse trigonometric. Inverse trigonometric is required, trigonometry is required for the entire calculus. Okay, fine. So all the very best, do well, and don't neglect any chapter. Even 1 mark is very, very important. It is going to decide your 4 years of engineering studies, undergraduate engineering studies. Okay, all the very best. Do well, give you 100%, be dedicated towards the studies, and make sure you're writing simultaneously. At least the properties is made a note by you in one separate page. Okay, all the very best, do well, and God bless you all. And lastly, do share, like, and subscribe to our YouTube channel, Math Universe with Dr. Naseer Ahmed. Thank you all.